You're watching the Intel Network and Edge V Summit series with our focus today on the network at the edge. Despite a decade of promise, Industry 4.0 has largely failed to achieve the wide-scale adoption rates that were predicted. So what have been the reasons behind this, and how can the emergence of edge technologies and solutions, coupled with 5G networking, help SMEs and manufacturing companies solve their industrial problems? And joining me now to discuss the challenges and opportunities are Mark Olding, Chief Marketing Officer, EXOR International; Caroline Chan, VP and GM 5G Infrastructure Division Network Platform Group at Intel; Brian McCarson, VP Internet of Things Group and Director Industrial Systems Engineering and Architecture at Intel; and Bob Pike, GM Smart Edge Division at Intel. Good to see you all. Thanks very much indeed for joining us on the program today.
Thanks for having us.
Yeah, pleasure to be here.
Yeah.
Mark, EXOR has been providing solutions, specialized solutions to the industry for decades now. You're well placed to identify and deal with the corresponding challenges. This journey towards smart manufacturing hasn't been easy. What do you think are the inherent problems with respect to realizing Industry 4.0?
Well, I think that there are various factors. It's never going to be particularly simple to answer that question. But I think that one of the main issues is a mindset change. As you correctly said, Industry 4.0 has been spoken about since 2011. So we're coming up to the 10th anniversary of this particular talk of technology and benefits. And the technology industry, which includes us, of course, has really shot our own selves in the foot, because we have continued to speak about the benefits of Industry 4.0 for the manufacturing sector, when for a long, long time, the technology was never really there to actually implement these particular benefits. So what's happened is it's created a tremendous amount of cynicism by people, which has lasted over many, many, many years. What this really does lead to is that we've been speaking to the wrong sector of people. We've been speaking to basically everybody, when really 90% of the technology adoption curve really do not love technology. It's only the sort of 5 to 10% of visionaries who really love technology, who would be very happy to adopt technologies which are still very preliminary, still very new, where there are still some problems. The vast majority, the 90%, really do not want to have problems. They want to have standards, they want to have industry standards, and they want to go from there. So the one set is a mindset issue. And you can see the difference between the manufacturing sector and some other sectors. For instance, AWS. AWS was brought about by a couple of engineers who inside Amazon decided, hey, we should use our own infrastructure, which we built up for the logistics and the warehousing, to actually start selling that to third parties. It's that type of mindset which is required also in the industrial sector to continue. What we find as EXOR, apart from trying to address that mindset issue, which is done through trust really more than anything else, we also come across 5 principal problems that we need to try to resolve for people. And this is where we move more over towards the technology problems as opposed to the mindset problems. The first of which is systems. We go into companies and they tell us they have a vast array of machines, a vast array of protocols, which is tremendous. I mean, we ourselves have over 200 protocols we speak to. There are a lot of other companies who do the same, and a lot of them are needed. The second issue is that these manufacturers, they say, well, what are we actually going to do with all this data? Even if they do get connected and all that technology issue is put about, what are they going to do with this vast quantity of data? In fact, it's quite overwhelming. What pretty needs to be happening for that is to some sort of selection to take place before the data goes to the cloud. The third issue is they worry about geographic dispersion. A lot of companies have very many locations around the country, around the world, and they really concern themselves how they bring all that data in a secure manner to one location. Then we're left with legacy machines, a very classic brownfield type of idea where it's connected to the protocols, the systems issue I mentioned before, but this is also the fact that it's very hard to rewire a factory once you've done it. And so there are a lot of legacy issues that address there. And finally, people want to know how the hardware that exists at the edge to allow them to do this Industry 4.0 benefits is going to look. Is it going to be scalable? Is it going to be flexible enough to cover all the machines they have in their actual factory? So we have these 5 principal problems that I think that we need to, or we're trying to address. And interestingly enough, for this particular discussion, the main solution to all those 5 problems takes place at the edge.
Thanks, Mark. And let's open this up to our other guests. Caroline, would you like to express your thoughts as to what these inherent problems are?
So, I mean, Mark really described the problem really well. This is not a solution looking for a problem. The problem that he described, I think we are at the right time to solve it. The 2 things that really happen. Number one is the wireless, especially 5G, is really starting to give not just a connectivity, but it bundles in a different type of algorithm that allows ultra low latency, that one of the issues that he brought up. And the fact that it has a low enough TCO that can connect many devices. That's another issue that Mark mentioned. And most of all is because the network has been going through this network transformation, the virtualization makes the network looks more like a compute issue rather than just a connectivity issue. It inherently allows a lot of the software to be residing on the edge to analyze the data, capture the data before it goes to the cloud. So in combination, the 5G, the network transformation puts it a very good foundation to start, working through the 5 issues that Industrial 4.0 faces.
Brian, have you got any views on the problems that we're seeing here?
Yeah, I think what Mark stated is exactly right. When we first started talking about Industry 4.0, it was more of a promise or a vision of what we could achieve if we brought all these technologies together. The reality is not all those technologies were ready. And even when we had some preliminary technologies, there's still some major challenges. Mark mentioned, over 200 languages or protocols that are being spoken in his factories. And this presents a massive communication challenge. And it makes it very difficult to try to seamlessly integrate new software capabilities. And when you're trying to deploy AI at the edge, and you're having to overcome all these communication firewalls that get in the way of elegant software, this can really slow things down. And in many cases, it can make it either cost prohibitive or technologically prohibitive to the point that you just don't have enough ROI. So for me, starting to overcome these barriers in how machines communicate with one another, the connectivity technologies that they use, and understanding that in a multi-tenant environment, you're going to have to bring these machines and applications closer together. That's one of the biggest barriers that we're going to have to overcome in order to really achieve this promise or vision of Industry 4.0.
Thanks, Brian. Mark, if I can ask you about SMEs and small and medium-sized businesses, how are they gearing up for 5G and AI? And what are their specific challenges when compared to some of the larger manufacturers?
Well, again, going back to what I said before, if you talk to the SME who are visionaries, then yes, they are thinking about artificial intelligence. Unfortunately, 5G still remains out of reach for most of these companies. It's extremely expensive to get that type of coverage. If you speak to the mainstream, as I mentioned before, this 90%, they would tend to laugh at you if you mentioned artificial intelligence. and start talking about that was first of all spoken about in 1952. And the idea of 5G just isn't there. So again, we have to be very, very careful in terms of who we are, our target, who we are trying to address. Because I think, as my other co-presenters have mentioned, 5G does promise a great solution to these things in combination with something that works at a very high level at the edge, and the computing power at the edge in an environment which, as I mentioned before, is a place where people fix things with a hammer. It's hot, it's dirty, it's humid, there's dust, there's grease, there's oil. People are not going to treat it as if it were an iMac or a beautiful PC. They're going to smash it around, and the hardware has to remain in place and work perfectly for at least 5 years. That poses a tremendous challenge from a technological point of view of being able to put the computational power that is needed to in combination with 5G to make these things work. So I still think we are a little bit away, and as we are a little bit away, we have to be very careful the target audience that we speak to. Otherwise, we're going to scare again the mainstream. And if I may add one last thing, because it's this mainstream. The whole point about Industry 4.0 is that it's disruptive technology. It's supposed to completely change every industry. People are able to use their own understanding and knowledge of their own company, their own sector, and digitalize that, and maybe even sell that particular knowledge onto others. If we don't address the adoption curve in a correct way, what will happen is that we'll be left with the very major, massive enterprise players who are able to afford to have a private 5G network, for instance, who will gain tremendously, and will lose a great deal of opportunity from these SMEs.
Brian, let's look at how we can accelerate this implementation. How critical are standards and open source in driving this transformation?
Oh, it's absolutely essential. If you look at what's happening in the 3GPP environment around trying to coalesce an entire set of industries, this is essential for us to achieve some of these promises of 5G that are being discussed. So that's one area that must continue, and major kudos to all those who have been involved in the evolution of 3GPP over time to get us to where we are today. But our work isn't done. In a factory that has real-time capabilities that need to be deployed in order to manage machines, control the output of machines, measure and record product quality control parameters, and dynamically feed those back to machines in order to prevent products from being built that would ultimately have to be discarded or reworked. All these things require capabilities like time-sensitive networking and time-coordinated compute over both local and wide area networks. And this is going to require a collaboration across a variety of different industries and a variety of different machine builders if we expect a factory to be able to be orchestrated. When I think about how a factory runs, I like to think of an orchestra. And we have all these different instruments, each with their own purpose, but they all have to come together in a unified way. And I view the standards world as not necessarily changing the players themselves, changing the machines themselves, as much as I view it as providing a conductor to help all these systems and machines harmonize with one another. And another area that I'm seeing exceptional progress in is the Open Process Automation Forum. Intel's heavily involved in that, as are a few other very critical players in the market, both solution and ingredient delivery players and the companies themselves that own these factories. And standards like the OPC UA, I think, are starting to show some promise at helping us overcome some of these communication barriers that Mark talked about earlier. And my belief is that if we continue to invest in this area, it won't inhibit innovation by any means. It'll make the mundane easy, and it'll make it simpler for companies to concentrate on their precise value proposition in the market and not have to waste so much time with all the overhead needed to try to get all these disparate devices talking to one another.
Thanks, Brian. And we'll continue talking about 5G now. Caroline, how do you see private 5G or CBRS style shared license networks playing out with the enterprise?
I think it gives a certain level of controllability and flexibility to the enterprise. I actually happen to sit on the board of a CBRS. We talk about that extensively. It doesn't mean there's not a role for the operator. The operator very likely will come in and manage the network and run the best known methods for the enterprise if so desired. But it gives a flexibility to the enterprise to say, I would like my network to be certain ways. I would like to retain data in certain ways. It's a variety that in the previous generation, when we try to bring the wireless into the enterprise, we often fail because the network today, up until 5G, is really designed for the smartphones. Really designed for the consumers. We really never took a view of what would enterprise like. I think for 5G, and there's a new release coming out of 5G NR-U, really started saying, okay, this network we need to design from the ground up, including some of the algorithm, the security protocols, the ability to optimize and collapse the stacks that ranging from 3GPP to non-3GPP. And that's a key point. Back to what Brian was talking about. You have to make it easier, integrated, and consumable for the CIO, the factory owners to take it on. And I think that having the concept of a private network started changing the mindset of most of the telco design engineers to say, this is what the network should be operated, not so much from a macro consumer driven, but more from a private and enterprise driven angle. I think it's a big step forward to make 5G, the promise of 5G for Industrial 4.0.
Thanks, Caroline. And Bob, how do you see private mobility or shared license networks working here, especially as Caroline just mentioned, this need for stronger security?
Well, I think private mobility has really been kind of our focal point for the converged platform we have. We one of the underpinnings of the design of the platform was to take LTE and make it more consumable by an enterprise. I remember meeting with the first few enterprise clients that we met with, and I got some really wonderful advice from one of them. It says, when you think about the edge, there's so many threat vectors. You should begin with security in mind. And actually, this is when I first met Caroline, and we really aggressively worked inside of Intel to think, how do we secure the edge? So we began with the idea of zero trust. That nothing trusts anything. You have to build the trust chain natively on each kind of, from endpoint to application policy. And we leveraged all the wonderful assets that Intel has in silicon from a standpoint of key management certificates. So we thought about this from both insider, nearsider, farsider kind of threats. There's real kind of concerns. So auditability around it. There's just so many things we tried to do, and we've consistently been challenging ourselves. This is why we're consistently interacting with the security teams inside the industrial or factory facilities to just challenge to make sure, because security is a kind of a never-ending journey. Some of the new FIPS requirements are helping us kind of even get even more prescriptive around it. It's the whole idea. You got to protect it, the data when it's sitting still, when it's in flight, and when it's being processed. There's some new technologies coming out called SGX that I think is even going to advance the security further. But again, there's no better, kind of work than to make sure we protect the industrial and the manufacturing facilities of the world around.
Thank you, Bob. And Mark, have you got some additional views on security?
Yeah, I just wanted to add one point, is that I think that the work that Intel has done, both on a software and also hardware basis for TSN, time-sensitive network, has also really helped the other part of the triangle, as it were, of issues that need to be sorted out. And that's whenever I speak to a factory owner, usually the thing that they are most proud of is the lack of human incidents, so the safety of the people that work there. And time-sensitive networking really does help, or will help, with that particular issue. So the work that Intel has done on that, so as well as the security of data, the work that Intel has done on the security for people indirectly via the work on TSN, I think is extremely important.
Brian, given that the network edge is getting closer and closer to the factory, how does this impact the cloud layer or the machine layer? Is this a new compute layer being added, and will this result in just increased complexity?
Well, I wouldn't say a new compute layer is being added. There's a compute layer at the edge today. However, the complexity and capability of that layer is advancing. What we need in order to deploy artificial intelligence in a factory environment isn't just about the edge or the cloud. It's about a harmonization between the edge and the cloud, and how that network infrastructure brings these things together seamlessly. But if you think about what does it take to deploy artificial intelligence at the edge, if I have a complex algorithm or model that I need to deploy in order to monitor my machine's health, look for the quality control parameters of products that are being manufactured on my industrial line, there's a lot of compute capability that's required right there at the edge. It's not cost effective to send all of that information to the cloud and have all of your processing for inference or even the simplest machine learning capabilities that you might want to perform on time series data. To have that all be sent to the cloud can create a massive networking bottleneck. It can be expensive from a network infrastructure cost. And in some cases, it would be absolutely ineffective. In some manufacturing environments, you need to have as much as latencies that are measured in microseconds in order for you to protect the health of the machine or to adjust the parameters on the machine at the first sign of a quality control issue being detected from one of your real-time analytic capabilities. And even at the speed of light, you can't go all the way to an off-prem cloud-based infrastructure, perform all that analysis, and send a decision back over the network to the machine in a matter of microseconds. You would need to have that data center to be on-prem. And the reality is, for many factories, that's just not cost-effective for them to have their own on-prem data center. So this new layer at the edge that's emerging is new only in terms of how complex and sophisticated the computing resources are. It still is residing in a layer where you might have typically seen an MCU or an ASIC that's simply collecting sensor data and pushing that up to the cloud in a more traditional IoT environment. But with this era of artificial intelligence finally starting to become accessible to more factories in the industrial environment, that layer now is capable of advanced inference, and eventually things like federated learning could start to emerge. And so if we start building in the advanced computing, storage, and connectivity capabilities at that edge, we make that machine future ready. And if we start concentrating more on developing software that's in a microservices, multi-tenant friendly configuration, we also make that combined solution more future ready, and make it possible to go deploy applications much easier without the traditional complexities of trying to link into a number of different proprietary communication protocols or connectivity protocols in the more traditional historical industrial landscape that we're used to seeing.
Thanks, Brian. Mark, do you want to pick up on something that Brian has just said?
Yeah, yes, I would. I would like to again emphasize how important the edge is, this edge hardware, I mean, because Brian is exactly right. Sometimes these edge devices are being asked to produce, to capture, to analyze data, and then to send to the cloud the excess data that is not needed for the real-time applications. The quantity of power that is required to do that is tremendous. So I completely agree. I think that the most obvious, key to adoption of Industry 4.0 is very powerful, very rugged edge devices.
Great. Bob, can I come back to on-prem? Based on your experience, what are some of the benefits that you've seen from industrial customers who are implementing on-premise edge technologies?
Well, I think there's two areas that in an industrial setting, especially in a manufacturing setting, time matters. Time matters in the productivity of an industrial engineer, of how quickly you can move things through the factory, getting parts to a location. Anywhere where we can take time out of the equation and give it back to the factory is kind of a positive end result. And that's probably the most exciting things to us, is watching how excited somebody gets for just saving a few minutes on something. Some of it has to do with the fact that we now, with these edge nodes, have a converged state. It's from top to bottom virtualized state. So you've got networking elements, you've got the capacity to have an application running there, you have the access methods terminated. So you can set policy to be able to make changes very quickly, which would have been very difficult to do in kind of the stovepipes that exist inside the factories. And so I think that's what's been interesting, is watching the excitement around time and then helping an industrial engineer's experience so that they make better decisions, they intervene quicker. I think the brownfield pieces are, some things that we're seeing some wins in that we didn't expect initially. But again, that would be really the anchoring. I mean, when it comes down to it, you either have to financially make sure this is a win. Obviously, you knew to do, but time seems to be an area of key concern. So that's my observations.
Thanks, Bob. Caroline, time's an issue, finance is an issue. Is there a way of future-proofing this enterprise choice?
I think Mark mentioned that, right? Anything that goes in the factory floor has to be there 5 years minimum. That's why we really looked at it's really a disaggregated software and hardware approach when we built out this 5G network and the edge network. If we're putting something that's ruggedized, dust-proof and so on in there, the software needs to be upgradable. Even as 5G rolls around, we try to, actually the industry has to make it more or less a design principle that this is going to be a upgradable from network for 5G as a different release comes out. You see that in 3GPP, you see different 5G ACIA, which is a standard body really focusing on taking 5G into different industrial, different enterprises. We work with ORAN, for example, and another one that I'm very familiar with, the TIP. Really look at the cloud principle, the cloud native, the cloud service provider point of view to design something that's both IT, OT, and CT, but you really start focusing on the evergreen aspect, using software, but riding on a hardware that has a much longer shelf life.
Thanks. And Mark, let's dive into some specifics, shall we? What are some of the Intel-based products and solutions that you've adapted, and what specific capabilities do they address in your factories?
Okay, well, we are a technology producer as well. So we have our factory behind, which you can see, a new factory which we are should be in operational 100% by the end of this year. And so that's given us the opportunity basically to tackle firsthand all of the problems that a factory owner would have when they're coming to the very enjoyable position of setting up a greenfield site. And remember, we are a technology provider, so really we should be able to solve all the problems. And what we found, going back to, again, this thing about the edge, is that it's so key. So we have developed, with the help of Intel, a SOM. It's called the GigaSOM. It has an Apollo Lake SoC with a Cyclone FPGA on exactly the same SOM, which starts at least to give sufficient power, both visual and computational power, for us to actually start to use it and be able to do that produce, capture, and analyze that I mentioned before.
Thank you, Mark. And Caroline, how is Intel supporting EXOR in its 5G use cases, and what Intel technologies are being used?
We provided this reference stack. We call them Flex RAN, or outside, a lot of people refer to that as a virtualized RAN stack. We provide them with has both LTE and 5G, and we lay on top of it openness and the smart edge software that the Bob's divisions come out of. We clearly work with a lot of the IoT software from Brian's organization. We really put it together as a solution stack rather than just a piecemeal, make it simpler to consumable. We setting up different test beds inside of Intel to continue to innovate on top of the 5G. As I mentioned before, the different releases coming out. In fact, we just released a software stack that has a TSN element in it. We'll be working through collapsing a multiple different, even non-3GPP stack. Looking forward to see how do we make the software much more integrated and much more diverse beyond just serving the consumer market, really targeting the enterprise. So we'll continue to work with industry providers like EXOR to, as 5G evolves, we'll continue to enhance our software as well as a silicon portfolio.
Thank you, Caroline. And indeed, thank you to all of you for discussing how we can accelerate this Industry 4.0 transformation. And don't forget, you can watch more interviews and discussions on edge networking right here as part of the Intel Network and Edge V Summit series. But for now, thank you for watching and goodbye.